Hi, in this video we are going to see about mobile radio propagation, free space propagation model. Introduction. Propagation is a term used to describe the signal transmitted from the sending station to receiving stations to ensure satisfactory performance of a wireless communication system. Propagation models used as a suitable low-cost alternative for site measurements. Propagation model predict the average received signal strength. Free space propagation model. The free space propagation model is used to predict received signal strength. The transmitter and receiver have a clear, unobstructed line of the site path between them. The free space model predicts that received power. The free space propagation model decays as a function of the transmitter-receiver separation distance raised to some power. The example is satellite communication system, microwave line of sight radio links, free space equation. The free space power received by a receiver antenna which is separated from a radiating transmitter antenna by a distance d. The free space equation shows that the received power falls off as the square of the transmitter-receiver separation distance. This implies that the received power decays at a rate of 20 dB per decade with distance. Given by the free space equation is denoted by P suffix r of d, where Pt is the transmitted power, Pr is the received power which is a function of Tr separation, and Gtx is the transmitted antenna gain, d is the separation distance in meters between transmitter and receiver, and L is the system loss factor not related to propagation. Lambda is the wavelength in meters. Activity. Effective aperture A is related to the gain of the antenna, where gain G equal to 4 pi AE divided by lambda square. Lambda is related to the carrier frequency by lambda equal to C by F, which is equal to 2 pi C by omega C. In Friis equation, GT and GR is dimensionless quantities. The isotropic radiation is an ideal antenna which radiates power with unit gain uniformly in R directions. The EIRP equal to PT to GT. Path loss. Path loss is measured in dB. The path loss is the difference between the effective transmitted power and the received power. The path loss may or may not be included the effect of the antenna gains. The path loss, which represents signal attenuation as a positive quantity measured in dB. It is defined as the difference between the effective transmitted power and the received power. The path loss for the free space model when antenna gain is PL equal to 10 log of PT by PR, and which is equal to minus 10 log of lambda square by 4 pi square to d square. The path loss equation is given in the slide. It can be expanded to given equation in terms of distance and frequency of operation. The free space model is only a valid prediction for PR in the far field of the transmitting antenna. This block diagram shows the free space radio circuit, which consists of transmitting antenna, which is a isotropic antenna, and receiving antenna, in which the effective area is AT. The separation between the transmitting and receiving antenna is given by the distance d. The power transmitted by the transmitting antenna is Pt, and the power received by the receiver antenna is denoted by Pr. Fraunhofer region. The far field or Fraunhofer region. A transmitting antenna is defined as the region beyond the largest linear dimension of transmitter antenna aperture and the carrier wavelength. D is the largest physical linear dimension of the antenna. Close in distance, it does not hold for D equal to 0 and close in distance D naught. The received power at reference point is given by this equation PR of D equal to Pt Gt Gr lambda square divided by 4 pi square D square into L. Received power level. The received power levels are mentioned in dBm or dBW. Units are used to express received power levels. The received power level is given by PR of D equal to PR D naught into dC by D the whole square. Assessment questions. What is free space equation? The free space model of propagation refers to, according to Friis equation, which one is the correct answer? Thank you.